let's talk about homework series 1.2. So again, just as a fair warning, this video is going to be kind of long. Lots to cover. I'll try to cover in reasonable depth, and so if you have questions, hopefully it takes care of it. So these problems will be ratcheted up a little bit compared to the homework 1.1, but that's kind of natural, seeing as they should build on one another. Anyway, let's get to it. So we need to determine whether or not each of the following lines below are defined to be parallel, perpendicular, intersecting. And so there's this hidden kind of skill in here. To know the parallel, perpendicular, intersecting, we have to do two things. One, we're going to have to find the slope of the line, and then two, we're going to have to interpret it. And so you might want to get those notes out or have them handy, because if you don't have a sense of what the rules are for parallel, perpendicular, or intersecting slopes, you're going to have a pretty hard time understanding the explanations you're about to see. So anyway, let's get to it. So if we're going to tell the parallel, perpendicular, intersecting, we have to find the slopes first. In this particular case, for this particular problem, they were actually given to us in equation form. And so from the previous homework, if you notice that these are in y equals mx plus b form, it's just a matter of knowing where to look for the slope. And so the slope for the first one is going to be 3. The slope for the second one is going to be -3. And so that's the skill part that's over. Now the reasoning part, what we have to interpret, is now you have the slopes, what do you do with them? Well, if we have a slope of 3 and we have a slope of -3, we can call those opposite numbers, but they don't fit into either the parallel or perpendicular category, because parallel would mean that slopes are the same, perpendicular means opposite reciprocals, and so this is going to be neither or just intersecting. Okay. For the second one, we're going to follow the same procedure. We're going to have to find slope. Now for this one, we're going to have to use a slope formula. Please recall the slope formula is change in y over change in x. Another way to look at that would be the same as like y2 minus y1, which would find you the change in y, over x2 minus x1, which would find you the change in x. So for the left-hand side, calculating the change in y over change in x, the y goes from 8 to 20, so that'll be a change of plus 12. We can also accomplish that by subtracting. 20 minus 8 is going to be 12. And for the second one, we go from 9 to 11, so that's going to be a change of 2. Reducing this, we have 12 over 2, so our slope is just going to be 6. On the right-hand side, let's go to green here. The slope is going to be change in y over change in x again. Well, this goes from 3 to 9, which will give us 6. And this will go from -1 to 0, which will be 1. And so the overall change, or overall slope, excuse me, is just going to be 6. So that's the skill portion. Now the reasoning portion is interpreting what to do with these two slopes. Well, if we notice the two slopes are actually the same value, that means these have to be parallel. So same slopes means parallel lines. Okay. Ooh, excuse me. Moving on to the third one, again, we just have a set of points, and so we're going to use a slope formula again. I'm not going to write it a second time, we'll just start interpreting it. So the slope on the left will be change in y over change in x. So this goes from -2 to 8, so this will be an overall change of plus 10. Again, we can also get this by subtracting 8, subtract a -2, 2 negative, make a positive, so we have 10. The change in x goes from 0 to 2, so that's a change of just 2. We can reduce it if we need to in a minute, but let's go ahead and move on to the second one. So we have a slope going from 3 to 2. 3 to 2 is a change of -1. The x goes from -9 to -4, and so that's going to be a change of +5. So it looks like they might be nothing here, but again, we didn't reduce the first one. Let's go back and do that. 10 over 2, if we cut both of those in half, we end up with 5 over 1. Or just 5. So now we have a chance to do some interpretation. So we compare these two slopes side by side. Two things seem to have happened. One, it went from positive to negative. It changed to the opposite. And the second, the fraction would have flipped. Well, that means they're opposite reciprocals. Opposite reciprocals means that they are going to flip the fraction and go from positive to negative. So this is going to be perpendicular. Okay. So to find slopes, we have a couple different ways we can do it. Sometimes we can just recognize it from the formula. Otherwise, we can use slope formula. That's just the skill part. The reasoning part is how these slopes interact or compare to call them intersecting, parallel, and perpendicular. If they're just going to have, if they're going to be the same slope, we call them parallel. If they flip and negate or change signs, opposite reciprocals, we call them perpendicular. And if they just happen to be opposites, we're going to call them intersecting. Moving on to midpoint. Midpoint, if you recall, is just finding the middle of numbers. There's a couple different ways we can do that, and that does include a midpoint formula. If we want the x value of the midpoint, we're going to calculate that by averaging our x's together, like x1 plus x2 over 2. If we want the y value or midpoint, we're going to do the same thing with the y values, y1 plus y2 all over 2. Okay. So that's what we can do here. Just apply our midpoint formula. And again, there's nothing fancy to it. We're just trying to find the middle value of the x's and the middle value of the y's. And so we look at 5 and we look at 2 and we look at the number right in between them. We can find that by averaging 5 plus 2 divided by 2. If we want to find the y values, we can go from 10 to negative 14. And so it'll be negative 10 minus 14 divided by 2. So just simplifying these for our midpoint, 5 plus 2 is 7. 7 divided by 2 is 3.5. Negative 10 minus 14 is negative 24. Divide that by 2, we get negative 12. And that will be our midpoint. Okay? A quick way to check this is just to look at the numbers and ask yourself, well, is 3.5 kind of in between 5 and 2? And it is. It's a reasonable number in between. Do the same thing here for negative 12. Is that in between negative 10 and negative 14? It most certainly is. So that's going to be a reasonable midpoint for us. So we can just continue this work on the bottom. If we want the x value of the midpoint or the y value of the midpoint, it comes from averaging the x and y values. Average is finding the middle. So let's average negative 2 and 7. So negative 2 minus 7 divided by 2. And then for the y's, we'll have negative 9 minus 21, also divided by 2. Let's do this. Negative 2 minus 7 is negative 9. Cut that in half, you get negative 4.5. Negative 9 minus 21 is negative 30. Cut that in half, we have negative 15. Okay, and that'll be the y value for the second one, or the midpoint for the second one. Graphically, this kind of confirms what I was talking about in counting. So here's kind of what I mean. If we need to go from A to B, but can only travel on the grid lines, that means we'd have to go over 1, 2, 3, 4, 5, 6, and then go down 2. If the entire journey is over 6 and then down 2, then half that journey, hence the midpoint, would be over 3 and then down 1. And if we look at that, we actually end up landing right on a grid point, and that point looks fairly close to the middle, and so we can trust 1, 3 to be the midpoint of this line. And so we don't actually need a formula to do this. We just have to acknowledge that midpoint's the middle, and there's lots of ways to get there. All right. Here we asked to find the perimeter of the shape, and so this is very similar to the question on the first homework in the same spot. And so we have a couple different ways we can get there. Just like the last time, to be honest, my favorite way is going to be Pythagorean theorem. I think it's the fastest way to go, and so that's the way I'm going to take this way as well. To use Pythagorean theorem, we need right triangles, but we can always make right triangles if we don't have them. And so if we want to find the length of this line, I just have to solve this right triangle. If I want to find the length of this line right here, it's just a matter of, again, creating the correct right triangle using that as a hypotenuse, which is this guy right here. And of course, for the last one, if I want to find this length, which I need for the perimeter, I just need to solve, using Pythagorean theorem, this triangle. The advantage of using Pythagorean theorem is that the lengths are much easier to find than, say, in the distance formula. For the green triangle, we're just dealing with 1, 2, 3, 4, 5, and then over 1, 2, 3, 4, 5. And so this is just going to be a 5 by 5, 3, 4, 5, yeah, right triangle. For the blue one, it looks like it's going to be over 1 and then down 1, 2, 3, 4, 5, 6, 7. Double count, 1, 2, 3, 4, 5, 6, 7. Yeah, so it's going to be a 7 by 1 right triangle. And then, of course, with the purple, it's going to be a 2 by, looks like 4 triangle. Okay. And so using the space below, let's solve the purple one first. So using our quadratic, using our Pythagorean theorem, a squared plus b squared equals c squared. The a value is 2, and the b value is 4. I'm pulling those right off the triangle above. So that'll be 4 plus 16 is c squared. So 20 is equal to c squared. And so square rooting both sides. So square root, square root. The c can approximate to be about 4.472. Okay, and so that's going to be this length right here, 472, or at least approximately that length. Let's solve the blue one next. So using the Pythagorean theorem, let's go 1 squared plus 7 squared is equal to our new c squared. 1 squared is 1, 7 squared is 49, which means our c squared value is equal to 50. So square rooting both sides, the square root of 50 is 7.071. Okay, so that's this one right here, 7.071. On the green, we have a 5 by 5, so that'd be, see, 5 squared plus 5 squared is equal to our new c squared. So that's going to be 25 plus 25 is equal to c squared. That's going to be 50. Now, we just actually saw that one up here, and so we can jump to c being also 7.071. So this actually makes our triangle an isosceles one, because we do have two lengths that are the same, the blue and the green. So to find the perimeter, we just have to add these together. 2. And so the perimeter of this shape, when you add all three lengths together, the perimeter, which I guess I'll write right here, the perimeter is equal to 18.614. Yep, we're good to go. Okay, so a little bit different than the first homework round. So the first homework I think is focused more on distances. This one's kind of integrating some slope and some midpoint into the practice, but certainly again something to look out for as we're moving forward. So let's look at number 4. So we're going back to kind of the notation phase of class. So again, we have to kind of interpret what we have, and now we're incorporating symbols as well. And so again, the thing to note is that we're dealing with a couple segments in this case, and the segments have to be congruent. Other than that, we don't know much, and so we do have this segment MC. Then we have this other segment, AB. We don't know if they intersect, we don't know how they're oriented, but what we do know is that we need them to be congruent, which means we're going to mark them with tick marks, and that's how we'll take care of that. For the second one, the thing to note is that we're dealing with, in this case, a line. So JF is just going to be 2 points on that line. Call it J and F. It has to extend in both directions past that point, because J and F are just 2 points on the line. It's not the entire line. The second thing is we have to bring in AR, so 2 new points, but they have to interact in such a way that they're parallel. And so again, we don't really know where these are. We do have an A and we do have an R. We have to make them parallel. Oops. So the R, let's actually move that A to here. The R has to create something that's parallel to the original. In this case, it's going to be an ray, and it's important to note the way the ray is written. It has to start at A and then pass through R. In terms of how they interact, well, we have this parallelism, so let's go ahead and mark them to be parallel. That should take care of number 2. So we have a line that's parallel to a ray. They're marked to be so. These are just sketches and there's representations, so these should be okay as written. Okay. So on this last one, again, interpreting first the symbols, we have this line TQ. So we have this T, we have this Q. It's a line, so it passes through both points. Perfectly straight, no problem at all. Then we have this other thing, QF. That's going to be a line segment. I should change colors. That's going to be a line segment. Please note that it shares a Q. It has to be drawn in such a way that it's going to be perpendicular. So we're going to draw QF straight down, make that point F. Perpendicular means it crosses at a right angle, so we drew it to be such, but we should also mark the diagram. And so we have TQ perpendicular to QF. There we go. So we have some terms here. Again, just kind of reaching back and kind of remember what these terms mean. Collinear means together. Co means together, like cooperative. Linear means on the same line. And so if we're going to draw things that are collinear, it's natural to start with a line, and we just have some things that appear on the line together. And so we can say A, B, and C are all collinear because they appear on the same line. Coplanar means they're together on the same plane. And so let's start with that. And so let's say we have this plane, kind of like, let's say, the plane of your desk or something. And we just have to choose points that are on it. So we have to make sure that they are all on the same plane. Again, the visual could be like these are all things that will say together on top of your desk. Okay, that would be a good kind of way to think about it. Okay. Non-collinear, well, that means that they're not going to be together on a line. So even though we're talking about things that aren't on the same line, we're going to start with a line. So let's say we have A and B; those are collinear, but let's just choose C to be non-collinear. Let's go ahead and take that one off the line, so that would be a non-collinear point. All right, so here we're trying to sketch a diagram. Again, we're going to do this kind of in pieces. So the first thing we have to do is sketch a line segment UM. So U and M appear on the same segment as endpoints. Now we have to define K, which means, hey, just pick a K and connect it back to M in such a way that it's going to be perpendicular, but not the same distance. And so I'm going to put it up here. So let's pick a K. So we had to connect in such a way that it's going to be perpendicular, but not the same distance. So I'll mark it using two different tick marks. For number 3, define a point C and then sketch UC. So connect it back to C and also to K. And so it's parallel to UM, so it's parallel to the purple one. It's congruent to the red one. And it's perpendicular to UM. And so there's really not a lot of places I can put it. I think this is the only one where I can put it, UMKC, because I have to connect it back to K, connect it back to U, in such a way that it's parallel, UM and CK. So it's parallel, top and bottom, but it's also the same length as KM, and also perpendicular to UM. And so a lot of different things going on, but that would be the picture that I'd have. Okay, so again, this is just going to be from the limited research we've done so far, but we have to draw something that looks like a kite. So a typical kite will look something like that. Trapezoid, and again, there's still lots of discussion to be had over like exactly what comprises a trapezoid, but there's a common picture of it, where we have at least one set of parallel sides. Parallelogram, again, just picking a typical picture. This is what a parallelogram is typically drawn to be, although there's still a lot of discussion about what connections we can make and what else we'd call it a parallelogram. For number 8, identify what is meant by each term below. You may have to do some recall. So pentagon, pent is the operative term here. Pent means 5, and so this is really a 5-gon. So it's a polygon that has 5 sides. It doesn't mean it has to be all the same side. It just has to be 5. So 1, 2, 3, 4, 5. There's a pentagon. Hex means 6, and so this would be a 6-sided polygon. So draw one that has 6 sides. Octagon, 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6, 7, 8. Not a great picture. We're just talking about something that has 8 sides. This question, again, it's like the last one. I'm not going to give you an answer here. I want you to kind of just give me a good quality answer to what's in your head about this. This is another piece of that puzzle. What is meant by the terms at least or exactly? Last step, let's talk about some algebra. Again, let's start with the rounding parts of this. So round each of the following to the 1,000th place, 3 decimal places. So recall from our previous discussion, if we want to round to the third one, we have to look to number 4. That 9 is bigger than a 5, or bigger than a 4, excuse me. And so it is going to kick up the number right in front of it. There we go. Round to 3, look to 4. This is going to cause a chain round. So this 9 that I'm pointing to with an arrow will kick up the one that I've underlined, but that in turn will kick up the 1, and that will kick up the 1, and that will kick up the 1. And so this will actually be 10.000. So this was going to kick it all the way up to make it a negative 10 even. Round to 3, look to 4. That is going to kick it up, so 0.127. If we want to round to 3, look to 4, another kick up, so it'll be 0.24, in this case 5. Alright, so here we have to find some slopes. And so this looks like it's going to be a sight read again, but again, we have a form which you're going to use, and y equals mx plus b. And so I might try to trick you because I rearranged the formula, but again, we're just looking for the number in front of x, and so the slope in this case is just going to be negative 5 over 3. For this one, this is in form, so this is y minus y1 equals the slope times x minus x1. So this one was kind enough to give you the form as is. We just have to know how to read it. And so the slope in this case, it's going to be negative 4 over 5. Okay, excuse me, last bit here. This is going to be a slope triangle 1. So going up the chain, if we go L, and we go all the way up, and then all the way over, that's a journey of plus 3, and then 1, 2, 3, 4, 5, 6, 7, and then 7. So our slope in this case, which is going to be like change in y over change in x, will do the same thing as 3 over 7. All right, lastly, for some algebra, we're going to have to do a bunch of solving here, but this is all second half. We've done this before. So let's do some cleanup on both sides of the equation. Let's do some distributing. So we have a negative 3 times 2 will give us a negative 6x. Negative 3 times negative 6 will be plus 18. 1/3 distributed through, a third of 9x leaves us with 3 x's. A third of 12 leaves us with just 4. Now in terms of moving things around, I'm going to keep the bigger of the 2 x's, which is going to be the positive 3. And so I'll get rid of this negative 6x by adding it to both sides. Okay, that cancels to 1. And so we're left just with 18 on that side. 3 x's plus 6 more x's make 9 x's, and of course a plus 4 will just follow down. Continuing our algebra, to get rid of this plus 4, we'll subtract it on both sides, of course. So we're left with 18 minus 4, which is just 14, and then 9x on the right-hand side. Last step, if we want to get rid of a times 9, we'll divide it by both sides. And so x is going to be the same as 14 over 9. Which is about 1.556. Okay, and of course that's actually approximated, but there you go. Okay, another function-born problem, but again, not one that's going to be too terribly bad. So we have this function called f that uses x, and it uses it by taking the x value, multiplying by negative 2, and then adding 1. And so now we're postulating what happens if I take the x and replace it with a negative 3. Well, every x then gets replaced with negative 3, so that's going to be negative 2 times negative 3, and then add 1. That together makes 6, and then add 1. So that if we take the function called f, replace the x with a 3, we'll end up with, in this case, 7. Okay, solving for x with a square, no big deal here. We first need to get rid of this negative 2. A common mistake here would be to say, well, we want to add negative 2 or add a 2. That's not going to be the case. The negative 2 is attached by multiplication, so we'll undo by division. So if we cancel out the negative 2's in division to make them 1, we'll end up with an x squared on the left. We have a negative 162 divided by negative 2. We'll end up with an 81. So we accomplished this last step by square rooting. Square rooting, what a terrible choice. Square rooting, there we go, and square rooting. And so we end up with x on this side. So we ask ourselves what number times itself makes 81. Well, 9 will do the job, but so will negative 9, so both answers must be represented because we don't know which version of the answer we want. Right? All right, so that's key number 2. Hopefully you're seeing some commonalities in the questions. That gives you a big hint of what's going to be on the test. And so that does it for homework series 1.2. I'll see you guys in 1.3.